how to convert CIDR to subnet mask. This is a commonly searched question, and in this video we're going to show you how you can convert the CIDR notation of a subnet mask to the decimal version or format of that subnet mask. Stay tuned. To the end of the video, we're going to show you a tool on landtechjobs.com that you can use to practice subnetting. And then, of course, in this video, we're going to show you 3 different ways to do this, 3 different ways to convert that CIDR notation to the decimal version of the subnet mask. So the first way is going to be what I would like to call the fast way. The second way is going to be the visual way that you see on your screen here. The visual way may not be for everyone because to some degree it adds an element of complexity to the conversion. However, whenever you have to go through a complex visual aid like that, it can actually solidify the concepts in your mind and make it easier to remember how to do this. So yes, while I know that this simplified version, the visual way may actually technically be more complex than the fast way, I do think that in conjunction with learning this the fast way and the visual way, you'll be able to do it the fastest way. So let's dive into the fast way, and then we'll get into the visual way, and then finally we'll finish with the fastest way to do this. So let's say we have a CIDR notation of /28. Now, bear with me, I'm not the best at drawing with this tool, but what you need to know, guys, is essentially /28 just means you have 28 bits that are on, right? So 28 ones in that IP address or that subnet mask are available, they're on, we can do things with them. So what does that look like? Well, whenever a computer reads an IP address or a subnet mask, it's really just reading a bunch of ones and zeros, okay? So whenever we read a subnet mask or an IP address, it might look like 255.255.255.240 if we're looking at the subnet mask. Or if we're looking at an IP address, it might be like 192.28.64.05, whatever, right? Whenever a computer sees it, it sees 1111001.111.1, whatever. You know, it's a bunch of ones and zeros whenever a computer sees it. But what this tells us is we have 28 bits. So CIDR notation is just letting you know how many bits are on. So I can literally just count these bits, and you can count pretty fast, right? So there's a maximum of 32 bits that can be turned on in an IPv4 address. If I just count up to 28, that will let me know how many bits are on, okay? And then we can figure out what the decimal notation is from that. We can derive the decimal notation from seeing how many bits are turned on and where those bits are turned on. So let's start. So I'm just going to count up to 8 for the first octet. So I'm going to do 1, 2, 3, 4, 5, 6, 7, 8. And then I would have a dot, right, because that's that first octet. But I haven't got to 28 yet. So I'm going to keep counting. I'm going to count another 8. 1, 2, 3, 4, 5, 6, 7, 8. Now 8 plus 8 would be 16, but I'm still not at 28. So I'm going to do another dot. I'm going to go into that next octet. I'm going to do 1, 2, 3, 4, 5, 6, 7, 8. All right, so 16 plus 8 is 24. I'm still not at my CIDR notation up here, so that must mean I've got to go into the last and final octet, the 4th octet. So we're at 24, was 25, 26, 27, 28. Okay, now that means that the other bits are turned off. Okay, so this is what the computer sees whenever it sees this subnet mask, right? These are all the bits that we have to work with in our network. So let's see, let's break this down, okay? So in case you don't know, each bit represents a value, okay? So the values, they vary, but 1 is going to be the value represented by this first bit. So if this first bit was turned on, it's a 0, so it's false, it's a null, it's a value that the computer doesn't read, so it's not going to count a 1. But if it was a 1, it would count this first bit as a 1. Now, the second bit is going to be a 2. Now, I know what you're thinking. You may think, okay, well, if the second bit is a 2, what does that mean the third bit is? Is the third bit a 3? Well, no, the third bit's not a 3. The third bit is actually going to be a 4. So the third bit, the computer sees that as a 4. The computer realizes and is programmed to say, okay, if I see a 1 in the third bit placeholder, I know that counts as a 4. Okay, so it uses powers of 4 to assign values to these bits. That's how the program works. That's how just the binary code works. That's the rules of the road. That's the lay of the land, so to speak. Next is going to be 8 because we're using powers of 2. Okay, so this next bit is going to be 8. And then we're going to have 16. So this next bit here is going to be 16. Getting a little messy here, but I like it. Next bit's going to be 32. Jokes in the comments below, I don't care. Next bit's going to be 32. All right, next bit, what's that going to be? Just 64, doing powers of 2 here. And then finally, the next bit is going to be 128. Okay, so that was a mouthful. I have to remind myself to breathe. Here we go. All right, so 64, 28. Now, if I want to get the values for each of these octets, all I have to do is just add up what the binary equals. And the more you do this, the faster you'll get at it, because it's really only a limited amount of numbers and computations that you have to make, and then you just start to memorize what the computations are. So you can literally get to the point where you can do this really fast in a day. Yeah, all right. So in this case, these first 4 bits are on, so I'm going to add up 128 plus 64 plus 32 plus 16. And I want to make sure I get this right, guys. I want to make sure I don't tell you the wrong thing. So if we do 128 plus 64 plus 32 plus 16, you're probably already ahead of me. You've got 240. So that is the subnet mask value for our 4th octet. Now, if we were to add up all of these ones, so if we were to add up the 128th value holder, the 64 value holder, the 32 value holder, the 16 placeholder, the placeholder for 8, 4, 2, and 1, we would get 255 as our value for this 3rd octet. And of course, these other ones are the same. So our subnet mask here in this case is actually just going to be 255.255.255.240. Okay, so that is how you do this. Okay, that is how you get the decimal version of a subnet mask just by counting. And I could do another example really quick, but I don't want to bore you. Let's go into the visual way. Okay, no, we don't want to review your program. We're just using it for this video. We might actually buy it. That's actually a pretty fun little program to use. Anyways, so the visual way, and I created this just this morning. I'm pretty excited about it. The visual way is a little more complicated, okay? But it may help you simplify your understanding of the numbers and why the numbers are the way they are, all right? And that might help you memorize this and feel more confident when you sit down and take your exam. So if we look at our hands and we kind of just draw a line at the back of our hand here below that last knuckle. So I'm just going to go to the little marker tool here, select this. I'm just going to draw a line right here. And then I'm also going to draw a line right here. And the reason I'm drawing a line here is because I don't want you guys to compare these numbers or associate these numbers with one another. So these red numbers, think of them at the moment as completely different from these top numbers, okay? Completely not related, all right? We're just worried about these top numbers. If I start with my fingertips and I say, okay, I'm gonna use this first fingertip, my first pinky. If I put my hands out flat, palms down on the table, and I look at my pinky here, the pinky tip is going to be the first CIDR notation of 1, right? And I'm just going to count up from there. How many total CIDR notation combinations are there? Well, if I count on my fingertips, 1, 2, 3, 4, 5, 6, 7, 8, right? That's 8 bits of our first octet, okay? And then I go down to that first knuckle, and I go across my first knuckles. Again, not counting my thumbs. I should add that. We're not counting our thumbs. And I just go across that first knuckle. All right, so I ended on 8 in that first octet. Now let's start our second octet on our first knuckle. I'll do 9, 10, 11, 12, 13, 14, 15, 16. Okay, so that first octet, I know that I'm breaking, or that second octet, I know I'm breaking out of that second octet at 16. And I know I'm breaking out of that first octet at 8. Right? And then here I can also see, okay, I'm starting that second octet at 9, and I'm starting the first octet at 1. Okay? So I'm creating boundaries like dividing lines in the CIDR notation, right? That's letting me know where the CIDR notation stops and where it ends for each octet. You can also use this method to just remember where each octet starts. And so in our case, it's 1, 9, 17, and 8. Or we could just do 1 plus 8, 9 plus 8, 17 plus 8. So 1 plus 8 gives me 9. Okay, so the next CIDR block for octet 2 starts at 9. 9 plus 8 is 17. Okay, so the next CIDR block for octet 3, that starts at 17. 17 plus 8, 25. Okay, so the next CIDR notation block, if you will, start for octet 5 starts at 25. So 1, 9, 17, and 25, you can actually memorize those if you want. And then if you forget, then you can just essentially go down your hands and count up. If you were to count from your fingertips down to that last knuckle, you'd eventually get to 32. 32 different CIDR notations. Okay, so now that we have discussed that, how is this useful and how does this help us convert from CIDR notation to decimal? Well, if I count from the right on my right hand, my right pinky, and I do the powers of 2 to get the values for each bit, then I can just visualize that down here at the base of my hand, and then I have this handy chart. So let's say I have a /28 in CIDR notation, and again, if I forget where 28's at, then I can either do this the fast way, and I can say, okay, it's 1, 9, 17, and 25. All right, so I just have to count from 25, 25, 26, 27, 28. All right, 28's right here on this finger, and it's going to be in my 4th octet because it's on that last knuckle. Or if you forgot, you can start all the way from 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. You can just go all the way around. But once you find where /28 is on your hand chart, if you will, all you have to do is go down, and that tells you that last bit that's on. So in our case, that last bit that's on is going to be 16. Bit 16 is the last bit that's on. So if we were to write out the binary, we'd have 1, 1, and 1. So all these bits would be on, and then we'd have zeros over here. And of course, we would be dealing with that last octet. So we would be dealing with this portion of the decimal version of the subnet mask. So we would know, since we're on that last row, since we're on that last block of CIDR notation, we would know that we have a 255.255.255 address. And so now all we have to do is figure out what that last octet is to get our subnet mask. And to do that, we simply want to add 128 plus 64 plus 32 plus 16. That gives us 240. And so we have a 255.255.255.240 subnet mask. Okay, so if I just move this over here, then /28 will be 255.255.255.240. And that is how you can get your subnet mask. Okay, so that's what 28 is. Now let's say we wanted to do let's say we wanted to do an interesting one like /8. Okay, well, how might we get that, right? How might we get /8? There's a lot for me to back out, so just back out all of that. Let's do /8. Well, what this is telling me is I'm in that first octet. Okay, so what I'm doing is essentially I'm working with that very first value of the octet. And on top of that, what's kind of interesting is I'm also all the way on the end here. But I just want to say here, just to be more clear, we're working with this value. Okay, first octet, second octet, this is the value that's going to change. And then these are going to stay zeros in your subnet mask if you're using CIDR notation. And then if you're using CIDR notation, for your third octet, this is the value that's going to change. And then that's going to remain 0 regardless. And if you're using CIDR notation, then this is the value that's going to change. And of course, all these are going to stay 255, right? In this case, these two would stay 255. And this one would stay 255. Okay? So there's some consistency here. But what's the fastest way to do this? Remember I said there would be a faster way to do this. And the fastest way to do this is just to practice enough problems such that you get these little memory tricks of your own that you build in your mind. So, you know, for instance, for me, I don't have to go through the effort of writing down 1, 2, 4, 8, 16, 32, 64, 128. Like I just know these values. So I don't have to go through the effort of writing them down. So that speeds things up. And so the fastest way to do this is to practice both of these methods, use both of these methods, and then essentially just answer practice problems to the point where you get it down. Once you get a /28, you're just going to know, okay, oh, that's past 25. That must be in the last octet. So immediately you're going to know that all these values are 255.255.255. And then you just have to figure out what that's going to add up to. You know, in our case, it adds up to 240. That's how you get good, guys. You get good through practice. Now, I want to say, landtechjobs.com, we have a subnetting tool that is located under mnemonics, memory tricks, and PBQs. You can sign up for the website. It's less than $5 a month. We have a lot of people, you know, who have kind of went ahead and they've signed up and they said they enjoy it. They think it's great content. And then two, you know, if you don't like it, I'll give you your money back the first 30 days. But it's $4.59 monthly. I'm trying to keep it super cheap, about the cost of a cup of coffee. And yeah, it supports the channel. It helps me make content like this, guys. It's something I enjoy doing, and I hope you enjoy it. Till the next one, take care.